My name is Daniel Farrell. I am a SDN intern, the SDN intern at Red Hat. I'm going to be talking about OpenDayLight performance today. So first, some objectives, kind of an objective-oriented person. What we're going to get out of the talk today, what I'm trying to message to you guys. So there's a tool called WCBench that I'm going to be describing, announcing, sort of, and giving some background on. A nice performance-related tool. I'm going to share some OpenDayLight performance testing results, things we found, some interesting conclusions that we can draw. And then in general, we'll start describing the state of performance testing for controllers. So that will be a kind of not OpenDaylight specific part of the talk, but it will be in the context of OpenDaylight because I work on the OpenDaylight integration team. And then hopefully start a conversation about where we want performance testing to go as a community, because as we'll see, there are some really important holes in performance testing in general for controllers. So we'll try to get some feedback there. So first, a very quick introduction to me. Again, I'm Red Hat's SDN intern. Do a lot of coding. Go back to that. So I worked on OpenFlow at Extreme Networks, and then I worked on OpenStack at Extreme Networks, and then I came to Red Hat in February to start working on OpenDayLight. Been touching lots of small things ever since, and then got into integration stuff, and done a lot of work there. 6,000 commits over the last year, and it's been that way for a long time. I love robots. I built a lot of robots. I built about a robot a year for the last 4 years. I'm on a team at NC State that I lead. We do a lot of cool 3D printing and other nice stuff, so let's talk about robots if you want. I love craft beer. This was me in London a couple weeks ago having a beer. Noticed the mustache overlay and the similarity to that meme picture where there's like the college student drinking the dark beer.
Craft beer?
Yeah, so like good beer, not water. Yeah, I also do a lot of biking in Raleigh, commute to work, which is nice. Do a lot of bike advocacy, trying to get more bike infrastructure in the area. Sometimes I'm able to combine biking and scuba diving. See on the right there, it's another favorite hobby of mine. Yeah, so let's move into some serious stuff. So an overview of CBench. CBench is a performance testing tool written by Rob Sherwood of Big Switch Networks a couple of years ago. It's pretty famous. I think it's definitely the most famous performance testing tool in the controller world. It's super simple. It basically just spams a controller with packet messages, waits for a flow mod, and then counts how many times it can do that. So yeah, not a lot going on there. We'll come back to that. So some issues with it. First, it's not actively maintained. The last commit was in November 2012. That's not great. It has pretty poor documentation. So out of 426 lines of code that regex finds C comments, believe it or not, there are 13 C comments. Say maybe either way. Yeah, so that's less than ideal. There are no unit tests, so it's kind of hard to change things and have any belief that you didn't break everything. It dumps its results in an unstructured or loosely unstructured format to standard out, so that's really hard for automation and like building it into Jenkins or any kind of continuous integration system or making its results more automatable. It's also written in C. You're unfortunately going to see me you might get the perception that I'm hating on C today. It's not that I hate C. I'm good at coding in C and things, but I think it's frequently, at least in the controller world, chosen when it shouldn't be. I think it's not an appropriate language in some cases. We'll have a few tools today to do that. Single-threaded, not maybe a huge issue. Could be a huge issue. Don't want to talk about it too much here. And its biggest problem is that it has a really limited scope with regard to what code it touches, right? So it's just doing that packet in there. There's a whole lot more to a controller that it's not touching. So that's sort of the big issue. So moving into the tool that I wrote, it's called WCBench or AppCBench. It takes CBench and it wraps it in useful stuff. There are 3 main scripts that are sort of the tool, wcbench.sh, loop wcbench.sh, and stats.py. As far as like a tutorial, I'm kind of going to walk us through those really fast. wcbench.sh, its sort of main function is, that's the part that directly wraps CBench. It allows you to automate lots of bits that people end up running into issues with. So I used to get tons of questions on IRC and via email about, okay, I'm trying to run CBench based on the wiki, and I'm seeing this issue or whatever, and it always turned out that they did something wrong with regard to configuration and like getting the initial system set up. So it was really important to automate that like in a detailed, robust way. So now I can say, well, use this script and patch the CI flags, and you have CBench, OpenDayLight installed, and set up, and you'll be good to go. Does all that stuff that I'm not going to go into. You can start ODL and issue the runtime configurations, the -o flag. This is an example of running a test. So again, make sure you're kind of parsing out this line in the flags. The -t flag says run it for this amount of time. That's a really important feature that I had to add as I was seeing results and getting feedback on them, because if you're using Cbench just out of the box, you're very likely to be using fairly short runtimes. And it turns out your results are basically statistically irrelevant if you're using runtimes of that length. Your standard deviation and relative standard deviation are incredibly high, so your result means very little. It's important to run for a long period of time and do a large number of runs to get statistically meaningful results. So moving on to, not moving on yet. It also supports running ODL and WCbench on different machines or the same machine, and it can do all the same stats collection that we'll talk about in a second without regard to how it's set up that way, as long as you have a network connection, obviously. Things I didn't touch on, you can pin ODL to a certain number of processors to make sure it's running out a resource limit. That's super important for doing good performance testing. Move around so make sure everybody can see. You can stop OpenDayLight elegantly, and you can clean up everything that the script does. So loop wcbench.sh, here you like rappers, so rapper. So in this context, it's passing the T2 flag, which does the same thing, run Cbench for 2 minutes. That -r flag, though, means it's going to restart ODL between runs. We will come back to that. It also supports pinning processors, like I mentioned. Stats.py does analysis of the results collected by wcbench.sh. The most important one in my mind is the relative standard deviation number. It supports 22 data points, including flows per second, RAM usage, IO wait, steal time, system load. All of those you can run stats against. You can do graphing, and actually that turned out to be the way that I found kind of all the interesting things that I found. Running, looking at graphs of different types of stats compared to each other with regard to run numbers. We'll see that in a second. So this command, which you can do the syntax for with the -h flag, obviously, but it's really verbose, so I didn't include it here, is going to graph the flows per second and the RAM usage against the run number. Here's that result. It's a little small. I tried to make it as big as I can, but it's a little hard to read. The top one is the flows per second value, and the bottom one is the RAM usage. Notice it going up, we'll talk about that. Has great documentation. So there's the table of contents, but I'm going to tab over actually, or Control-Shift-Tab over, and scroll through it. So it's on GitHub. Table of contents, I made it really big, so it's kind of awkward, but all kinds of good usage details. So there's an overview of usage, and then usage for various scripts, the scripts in detail, each script in detail. How to parse results, what all the results mean there. Nice detailed walkthrough of how to use it, from basically the fresh door 20 p.m. Until having all your results and analyzing them. How to contribute, where to raise issues, that you should raise issues, how to contact me, all that good stuff. All right, so Control-Shift-Tab back over. So that's wcbench.sh. I'm kind of moving into some test results now. I didn't say this earlier, but feel free to interrupt me at any point. Okay. So this is a relatively normal test result. This kind of shows what we would expect to see. Notice the fairly low relative standard deviation, 4.9. That's good. That's actually higher than what I normally get. I normally get in the 3s. The example I picked. Yep, moving on. So that's the important bit, standard deviation. This is what I call flail. I don't understand this particularly well yet, and you're going to hear that a number of times, and that's because this is an active area of research. I had a hard time submitting my slides in advance because all of this is changing relatively quickly. We're working on this. So very high standard deviation, 13.7, kind of all over the map. And I think based on conversations with Rob Sherwood and sort of there's also a lot of error messages coming from Cbench while that behavior is happening. Maybe it has something to do with dropping connections. Again, this needs attention. This is a to-do of mine and maybe other devs once LinuxCon is over. Decreasing performance is another thing that I see. So this is running without restarting ODL over like 2 weeks or something, spamming it for a very long period of time, lots and lots and lots of flows. Pretty obvious trend there. This is bug number 1395, targeted for fixing helium. So we're working on it. People are paying attention to it and stuff. This is increasing RAM usage, sort of my third and final interesting finding. Essentially, RAM usage increases roughly linearly over time. Other people have observed this too. Chris O'Shea, Casper saw this. Somebody on the mailing list a while back saw it. Sometimes it's more dramatic than other times. I think that's probably directly proportional to the flows that you pass through it. But yeah, so this is bug 1591. People are also paying attention to that. And, you know, as a cool thing, we got all this integrated into Jenkins. They're like actually a fairly small subset of wcbench.sh integrated into Jenkins. So now we're automatically doing this on a daily basis. Okay, so kind of moving from things we've done to things we need to do and discussion type stuff. Approximately halfway through the talk, probably not time with it. Anybody have any questions about what I've talked about so far? Yes.
Can you go back to the memory usage?
Yes.
What's the size of the time scale? How long?
It's 900 runs, which would be like a couple of days.
And every run you do restart the OpenDayLight controller?
No, so not if you do restart the OpenDayLight controller, you do not see this increased RAM usage.
That's actual what you are testing, right? You don't restart it, you just keep using it.
Yeah.
It uses Java, right? It uses JVM.
Yeah.
Have you been monitoring Java?
No, that's on the short-term to-do list. There are all things, a lot of things that I thought about with this RAM usage stuff. First off, it might not be an issue, right? Increasing unused RAM is wasted RAM, right? RAM should be used. Maybe it's logging things, but no. The short answer is no. We have to look at that deeper.
Well, we can talk later about Java performance and memory consumption and overall.
Let's talk about it because I'm no expert. I'm
the Java, demon.
Yeah.
Anyways, we can talk later.
Sweet. That's the kind of stuff I'm hoping to get out of this talk. So good.
Yeah, and the Java collector, once it starts kicking, if it works properly, you will see it perform degradation. If it doesn't work properly, you will see it like completely drop in performance.
Yeah.
So degrade and completely drop is not safe. I would love to see the graphs.
Yeah, let's talk about it a bit. But yeah, finding people to talk about these things with.
Question?
Yes, good.
What's the sustained number packet out per second for OpenDayLight?
So I'm intentionally not answering that question because I think it's not a useful answer. It depends on what system you're running on. It depends on lots and lots of different things. Kind of one of the points that I'm trying to get across here is that that magic number that comes back from Cbench is nearly meaningless unless you can start comparing it to other controllers and stuff like that.
Yeah.
But if you really want me to give you the answer, like in the upper 20,000s, is like 28,000 photons per second or so.
What's the hardware profile?
I didn't hear that too.
The hardware.
This is running on Linux Foundation servers. TechDeal, it's not here. You could have answered that. I think it's like a quad-core processor and 2 gigs of RAM, 4 gigs of RAM, something like that. But don't quote me on that.
Did you do J profile to see what's creating a bottleneck? For example,
that's what we're doing. We're fixing the group issues. We still have to. This is an active area of development. The results that I'm showing are very new. We haven't gotten around to doing that kind of stuff yet.
Because the problem with Big Search Beacon, when the first developed Cbench testing against Beacon was because of the OSGI. That's why the Big Search completely redid the whole project into Spotlight, and the performance went eightfold to 660,000 for packet out per second.
And asterisk, right? You can optimize that tiny bit of a code path and get that number super high, but it has almost no bearing on the important, sort of overall aspect of your performance, right? That's what one thing is I'm trying to make sure is clear.
Yeah, that's 30 times higher than OpenDayLight.
So that part of the code path is significantly faster.
And really, from an OpenDayLight perspective, the real bottleneck is the data store. So it only depends on the type of data store you have, and that's probably done with the old version of the data store. They've created a Scala database, and that will be very performant. So I don't know how usable it's going to be for them, but I know it's something that was one of the biggest features for green hydrogen and helium. And from an OSGI perspective, OSGI is actually not very much used. And I mean, it is an OSGI project, but it's only there to kind of hold the things together, but all the communication is not through Java or, I mean, it's all message passing with futures and continuations. So it's a new way that the internal of the AD style, and talking mainly for the, there's two sides of the controller, right? The AD style and the ND style. I sorry, don't want to.
No, please. I was probably going to be short on time anyway, so talk what you want.
But on the ND style point of side of things, all of them, everything is asynchronous and pretty performing from a pipeline point of view. So it will change these numbers, and that's some of the reasons why Jan and the guys have been so focused on performance.
Yeah.
It's been.
See some more of that in a second.
And cbench also is like for every packet out, I guess the controller doesn't know the MAC, and you'll have to do plugin. And the plugin actually duplicates the packet depending on how many switches you have.
Right.
It could be 1 to 3, and you get triple for your packet outs.
Okay. Interesting point. Let's talk about it more out of bed. Try to move on. All right, so what we're doing, hard right now is trying to fix some of these performance issues. And what I want to talk about with regard to having tools that characterize any controller's performance, not just ODL's performance, in more useful ways is a big deal. And let's move into that part of the talk now. So this is kind of a wish list of things that I would like to see from such a tool, and then we'll talk about some existing tools, and then we'll see that none of them even come close to matching the wish list. So obviously, it has to be open source. It needs to cover more code paths. That's the other big part. That's what cbench really sucks at is exercising a whole bunch of the controller. It should have good docs, not just docs about like what it does, because that's what the code is there to document, but why it does that, right? So I say this also to try to evangelize about that. Should have readable code, bought out variable names, elegant, implies simple design, good formatting, passing Hep8 and such, for example. Choosing your language well, so if you're going to be trying to build a community, you want people to be able to like read and understand your code quickly and contribute to it. So maybe not C, maybe Python or something like that, right? Unit testing is super important. I wish this could go without saying, but fortunately you can't, especially for dynamic type languages like Python. So this is I think an important one that's not talked about a lot. Community-enabled distribution. This is something that I saw not done well in a lot of the tools that I talked about. I'm going to talk about. So scripts are emailed around, you're linked to random tarballs or VMs, things like that. If you don't do this in the open and get the community to at least know that it exists and write documentation as you do it, give them the opportunity to contribute and give feedback, even if they don't. You are cutting any potential community building off. I really care a lot about community building. It's something that I think about a lot. So it would be great if we could support multiple controllers so we can compare one controller to another. That's something that we're currently unable to do with any tool. Yeah, so that's my wish list. Existing tools. So KCbench, first one. It's basically cbench exactly the same code base, same C code base, with some 1.3 overflow improvements added. I'm trying not to call it a hostile fork, but it's probably an unintentionally hostile fork. It's just hosted on some other website, and it never got merged back into master, and that's a little sad because it just should be straight merged into master. Oh no. I think it just wants to sleep. Cool, no problem. In a few minutes, you should remind me to play with that again. Sorry, technical issues. Let's do it from here for a second. Okay, so Jan scripts, they don't have a name as far as I know, but those are the ones we were talking about a second ago. I think I just registered all my commands at the same time. Sorry. Great, let's see. Yep. Okay, so Jan scripts, essentially what they do with the REST interface, so if you're here for the last talk, you heard some about, they load the REST interface with flows, and then they delete the flows, and it sees how long it takes to do that. That's actually pretty cool. That covers some functionality that we didn't cover before. Very readable code, well done in that regard. It's in Python. Not just that it's in Python, but it's also written in a readable way. Unfortunately, it's distributed dev to dev via email. So Casper, Chris O'Shea emailed me these scripts, and I guess they get emailed to him from Jan, so not great there. There's no testing, also not great. This one is a really interesting one. All kinds of cool things about this one, interesting things about this one. Sorry, this thing is sliding down. The audio was probably bad there for a while. OVS. So OVS is a fairly feature-rich controller testing framework written by a guy in India named Ganesh Shankar. it's really, again, very feature rich. It's very easy to model topologies in a fairly natural way, fairly complex topologies. You can simulate lots of different kinds of traffic, which is cool. You can view real-time stats about what's going on in this network that you've modeled, how the traffic is behaving, failures, various kinds of rates and things. Unfortunately, it's another one that's distributed dev to dev via a VM image and a tarball. That is literally, or I'm almost sure it's literally the only link to it on the internet, which is really sad. But so C-Dub, Ghostwright, my manager, just happened to know this guy, happened to talk to him about it, happened to find out about it, linked us together because I was trying to talk to everybody I could about finding performance testing tools. And then I got this link and I've been looking at it since. But yeah, if you want to look at it, you have to find my slide deck. There it is. So Ed used this phrase earlier at the developer roundtable or whatever that was called, the first thing of the mini summit this morning. Throw over the wall code approach. It's kind of like that. So he's really passionate about it. He's done cool work, but he's been doing the work himself without building any community, without putting it anywhere that anyone can check on it, without really talking to anybody about it. And now he's just dumped a bunch of code on everybody. And it's good enough code that it's not worth just ignoring, but it could have been a lot nicer if we hadn't done it that way. So I have to explain this, I guess. This is the documentation directory. It has these two files, dir structure and to. In dir structure, it claims to have all of these documentation files, which it doesn't have. But he's working about that. We had like a 3-hour call on Monday. I gave him a bunch of feedback on various things, and the main thing was that if we want the community to use this, it needs documentation. It needs significant documentation. He's working on it. So this is me grepping for test, and I did more than just grep for test, but this made a nice little screenshot. And yeah, those 3 files, those aren't tests. They're really small and almost empty, and they're not tests. There's no test. It's coded in C. I think that's an ideal. So moving on, next one, test on. You may have heard of this one. This is probably the most famous one I'll talk about. This is a framework for doing various kinds of SDN-related testing. It supports lots of different SDN devices, which is cool. Unfortunately, can I get a collective facepalm from all the Python devs in the group as you read over this code? Self.true equals 1, self.false equals 0. We have built-ins for that. Okay, so that's sad. It's coded like C, but it's Python. XCO, I'm going to disregard because it's closed source. It's also only half a test, the southbound part. How do you say the name of this company? Spirit? Okay. Spirent. It's one of those things I've read for a long time, never heard anybody say, so.
You can say big bucks.
All right. Yeah. Anyway, also closed source, disregard. I don't know whether they can support OpenFlow switches. If anybody does know, that'd be cool. Luis Gomez of the integration team has talked to them about it and gotten informal assurances that they might. So we don't really know whether it can be used as a controller test at the moment. And here's a really important slide. If you guys know about any other performance testing tools, I would love to know about them for controllers.
Have you looked into OF test?
Yeah, I actually contributed a lot to OF test. Back when I was at Extreme. But yeah, I guess that's not really, I didn't use it for controllers, I used it for switches, right?
Yeah.
Do you know of functionality that would be useful for controllers then?
Not necessarily, actually, no.
Okay.
But I think the equivalent for OpenDayLight to test the switch would be something cool.
Yeah. Exactly the inverse of that, right? Okay. So my contact slide is coming soon if you happen to think of any other tools there. So here, kind of moving into community discussion phase, I propose that we need a better performance testing tool for controllers. I think this is not just an OpenDayLight problem, this is an all-controller problem. And making assertions about performance right now with controllers is a tough claim to make, given the tools that I believe exist. So I would like to make a tool that sort of brings some sanity to this confused landscape. I would start with focus on OpenDayLight because that's where I work, and then iterate to generalize it, and that's a really important bit of this, so that we can try to build some community among other controller devs. And, hey, you don't have a tool either. Why don't we work on this together? I'm contributing ODL code, but I'm going to try to do it in a fairly general way, and then I can iterate to make it more general, and you can come work with me, and things like that. Let's talk about that. There's a document from IETF that describes a bunch of different types of controller tests. That's a little small, I bet. But it says benchmarking methodology for OpenFlow SDN controller performance, draft by some guy.
By the various guys.
Okay. Yeah. So starting with this is sort of a blueprint for some interesting tests, or at least to get some ideas going. There's a large performance testing section that iterates to make it more of a framework, so we can start with those tests, but then again try to generalize. Honor that best, what I call it, better tools wish list that I had a while ago. Python for fast development and readability. This is a performance test, but we can build it first elegantly and quickly, and then go back and optimize later. Look at the critical path, make that fast with C or assembly if we need to. Go ahead.
Yeah, I back on Python because our dev test engineers, they know Python better than they know C or Java.
And again, building community, right? If I spend a week understanding your code, then it's going to be tough for me to join that community, right?
And it's quick and you can rapidly modify it.
Yeah. And just do a lot of things with standard library calls. Solid docs. If you can't tell, I'm really into documentation, writing good documentation. I like to write Python docs as Sync style, so that I can render HTML and PDFs and things, so we can drop that on a website somewhere. And all the other obvious things. Testing, especially if it's a dynamic type language. Posting on GitHub or somewhere similar. Obviously open source, obviously style compliant, FF8. This is all very research-based though, so all the things you saw are very recent. This is recent and future work. So I love input. Anybody love people to jump in and help me with this. There's all my contact stuff. And that's pretty much all I have other than questions. Anybody have any questions? Yes?
Every time you make Astra,
I didn't hear you.
I perf in Mininet.
No, I've heard of that, but I've not played with it. Can you tell us a little bit about it?
I haven't.
iPerf is a TCP-based tester, so it's going to be testing packets through the switch.
Okay. The other part of it.
I mean, yeah.
Okay. Cool. Any other questions, comments?
Would be, let me just pick on it. Very nice work, and
thanks.
Pleased to see this. It would be nice to see your tooling as a project in OpenDayLight.
Yeah, it's in the integration branch right now. I'm a little conflicted. I would love to have some conversations about whether it should be hosted there or just on GitHub or what.
Or just, it's always a choice, but if it's a form of project, it's always nice to see that. It doesn't have to be controller related at all.
Yeah. I just released, tagged on GitHub version 1.0, so I was thinking about moving version 1.0 into the integration branch, and then just doing sort of major updates that way.
Yeah, it's been up with you.
Any other thoughts, questions, comments?
Do you have any? Do any of these tests have a definition of what a typical workload is, or are they just trying to hammer the controller? Because it's easy to write. You can either write two types of tests. You can write the simple one that is, so simple because you're just asking the controller something simple that it knows the answer to.
Right.
Or you could write the worst case one where, okay, I'm going to populate, equivalent of a 16 million route table entries. I'm going to populate every database and then delete things. You can worst case scenario whatever the backing story is by just. But the real valuable one is to find something that matches.
Real deployments and such.
Real deployments, something like the controller equivalent of the people who have web benches where they take and take back on traffic patterns and say, well,
yeah.
The pipe distribution is this and so forth.
Yeah. No, that's a great point. That's certainly something that when I say realistic scenarios and covering good code paths and stuff, that's what I mean. As far as I know, OFNet is the only thing that provides anything close to that functionality where you can simulate various different types of traffic at various inter-arrival times. Did you have something? Like a hand? No? Yeah. Sorry, it's all like a little thing.
$20,000, that's your business.
Cool. Any other questions, comments? You guys should ping me. We should talk about this more. Let's figure this out.
Maybe one more thing. Are you planning to have some kind of CI environment, continuously running benchmarks for controllers?
Yeah, I think you may have stepped in just after that. It's already integrated into Jenkins, the tool that I wrote, WC Bench, so it's running on a daily basis against ODL. This future tool that I'm talking about, I would love to obviously work into Jenkins as well for ODL, and I imagine any other controllers that jump on the bandwagon can do the same. I'm a little early, so you guys get to go get some more coffee or something.
Good. Thank you, Daniel.
My name is Daniel Farrell. I am a SDN intern, the SDN intern at Red Hat. I'm going to be talking about OpenDayLight performance today. So first, some objectives, kind of an objective-oriented person. What we want to get out of the talk today, what I'm trying to message to you guys. So there's a tool called WC Bench that I'm going to be describing, announcing sort of, and giving some background on. A nice performance-related tool. Going to share some OpenDayLight performance testing results, things we found, some interesting conclusions that we can draw. And then in general, we'll start describing the state of performance testing for controllers. So that will be a kind of not OpenDaylight specific part of the talk, but it will be in the context of OpenDaylight because I work on the OpenDaylight integration team. And then hopefully start a conversation about where we want performance testing to go as a community, because as we'll see, there are some really important holes in performance testing in general for controllers. So we'll try to get some feedback there. So first, a very quick introduction to me. Again, I'm Red Hat's SDN intern. Do a lot of coding. Go back to that. So I worked on OpenFlow at Extreme Networks, and then I worked on OpenStack at Extreme Networks, and then I came to Red Hat in February to start working on OpenDayLight. Been touching lots of small things ever since, and then got into integration stuff, and done a lot of work there. 6,000 commits over the last year, and it's been that way for a long time. I love robots. I built a lot of robots. I built about a robot a year for the last 4 years. On a team at NC State that I lead. We do a lot of cool 3D printing and other nice stuff, so let's talk about robots if you want. I love craft beer. This was me in London a couple weeks ago having a beer. Notice the mustache overlay and the similarity to that meme picture where there's like the college student drinking the dark beer.
Craft beer?
Yeah, so like good beer, not water. Yeah, I also do a lot of biking in Raleigh, commute to work, which is nice. Do a lot of bike advocacy, trying to get more bike infrastructure. WC Bench, and it wraps it in useful stuff. There are 3 main scripts that are sort of the tool. WCBench.sh, loop WCBench.sh, and stats.py. As far as like a tutorial, I'm kind of going to walk us through those really fast. WCBench.sh, its sort of main function is, that's the part that directly wraps cbench. It allows you to automate lots of bits that people end up running into issues with. So I used to get tons of questions on IRC and via email about, okay, I'm trying to run cbench based on the wiki, and I'm seeing this issue or whatever, and it always turned out that they did something wrong with regard to configuration and like getting the initial system set up. So it was really important to automate that like in a detailed, robust way. So now I can say, well, use this script and patch the CI flags, and you have cbench, OpenDayLight installed, and set up, and you'll be good to go. Does all that stuff that I can go into. You can start ODL and issue the runtime configurations for -o flag. This is an example of running a test. So in the area, sometimes I'm able to combine biking and scuba diving. You see on the right there, it's another favorite hobby of mine. Yeah, so we're doing some serious stuff. So an overview of cbench. Cbench is a performance testing tool written by Rob Sherwood of Big Switch Networks a couple years ago. It's pretty famous. I think it's definitely the most famous performance testing tool in the controller world. It's super simple. It basically just spams a controller with packet messages, waits for a flow mod, and then counts how many times it can do that. So yeah, not a lot going on there. We'll come back to that. So some issues with it. First, it's not actively maintained. The last commit was in November 2012. That's not great. It has pretty poor documentation. So out of 426 lines of code, that regex finds C comments, believe it or not. There are 13 C comments. Say maybe either way. Yeah, so that's less than ideal. There are no unit tests, so it's kind of hard to change things and have any belief that you didn't break everything. It dumps its results in an unstructured or loosely unstructured format to standard out. So that's really hard for automation and like building it into Jenkins or any kind of continuous integration system, or making its results more automatable. It's also written in C. You're unfortunately going to see me you might get the perception that I'm hating on C today. It's not that I hate C. I'm good at coding in C and things, but I think it's frequently, at least in the controller world, chosen when it shouldn't be. I think it's not an appropriate language in some cases. We'll have a few tools today to do that. Single-threaded, not maybe a huge issue, could be a huge issue, don't want to talk about it too much here. And its biggest problem is that it has a really limited scope with regard to what code it touches, right? So it's just doing that packet in. There's a whole lot more to a controller that it's not touching. So that's sort of the big issue. So moving into the tool that I wrote, it's called WCbench or AppCbench. It takes